In a world where space and time are intertwined, one man dared to challenge the status quo. His name? Dayton Miller. His weapon of choice? A flute. But not just any flute. This instrument held the power to unleash the ether, a pervasive medium once thought to fill the universe. Miller, a physicist by trade, a musician at heart, discovered a harmonic resonance within the ether. He found that his flute, when played with precision, could manipulate this elusive medium. His melodies, a symphony of science, had the potential to shift the very fabric of reality. However, a sinister force lurked in the shadows. The Einsteinian demons. These creatures thrived in the distortion of space-time, causing chaos and disruption.
All right, hello and welcome everyone. We are backstage here waiting for Reds to get back, and the debate shall be starting soon.
It is tails. Sorry, so Astronomy Live, since you won the coin flip, you get to decide who goes first.
I'll elect to have Alan go first.
Understood. Alan, if you would like to prepare yourself, here we go. And I'm going to set my little bitty timer here on my mobile device. All right, let's do this. So for 15 minutes, we are going to start that in 3, 2, 1, go.
All right, real quick, is my screen sharing? Did that go through okay?
Yes.
Okay, perfect. Okay, so here we are. We're going to take a look at some historical measurements and the history of philosophy, physics, and cosmology. So starting in the 1725s, James Bradley made a measurement of aberration with the star Gamma Draconis. The measurement corresponds to an arctangent that has an angle of 20 kilometers a second, or I'm sorry, 20 arc seconds. When you take that 20 arc seconds, that's a product of the arctan of V over C, where the V is 30 kilometers a second. Now, where'd they get this 30 kilometers a second? 30 kilometers a second comes from the ratios of Kepler's laws and Newtonian dynamics. So the asserted cosmology has measured this effect of 20 arc seconds of a drift and deviation of where the star is supposed to be versus where it appears to be, and it's off. And so that total amount gives them a ratio that corresponds to 30 kilometers a second to produce that angle, is what they're asserting. So we look here from Kravanovich, who says, at stakes was the layout of the universe represented by two models, the Copernican or heliocentric, or one where of a geocentric state or a geohelio state where the planets move around the sun and the sun moves around the Earth. Either way, those systems are stationary where the Earth is stationary. So what do we do with these measurements? Does this ratio mean that the Earth is definitively in motion? Well, the V over C relationship is a first order relationship with motion. So that does give good evidence. And that's why this guy says right here that these apparent motions of the star can only be explained by the effect of the Earth around the sun, and assuming the speed of light is constant. So assuming relativity is true and that the motion of the Earth is true, that would produce the effect. Now, we're going to see if this is mutually exclusive and if there's anything else that could explain these. Now, real quick, the geocentric model explanation is just the Earth is stationary. The relative motion of the stars produces that drift throughout the year. So for mutual exclusivity here, we're looking at a recap of history from Wilhelm Wien in 1898, who says that the best experiment given for the proof of heliocentrism is the aberration of light measured by Bradley. And then in the next page, he goes on to talk about how the experiments that give a negative result are starting with Arago, which is the experiment where a crystal prism was used to half cover a telescope, which when a star intersects with the midpoint of that, if the Earth is in motion, that should cause an additional deviation angle to keep that star in the center based on the refractive index of that crystal. What he found was that he didn't have to change the angle of the telescope to keep the star in the center. And so that's direct evidence against the motion being the cause, and the implication is that the starlight already comes in with that drift. So here's a quick little recap of what Arago did here. We got our zenith mount. We're looking up. Starlight's coming in. We got our crystal prism. Starlight should be deflected. If there's no deflection, then the implication would be that the Earth is stationary. The light already comes in with that, irrespective of any ether theories, because the motion is a dynamic cause. It's a dynamic event. It's a real thing. It's happening. So if that's true, then the distance traversed would have to increase because the light is being slowed. Because the V over C equation to predict aberration, there's only two variables in it, and that's the assumed velocity of Earth and the velocity of light. And we can only manipulate one of those things. So here we have some continued experiments that were done, but before we can get to understanding the interpretation of those, we need to understand the principles in which they were derived. So here we have Fresnel drag, which is the amount that light will be dragged by a transparent moving medium as a function of its velocity and the inverse of its refractive index squared. That will be how much velocity is translated. And this was derived under the principles of the classic effect of sound, the speed of sound being the square of the speed of sound being inversely proportional to the density of the medium in which it's propagating in. So under that same principle, Fresnel came up with this formula in 1818. It was tested in 1858 by Fizeau, where the speed of the running water was translated in the fringe patterns here. And you can measure the distance between these fringe patterns, and the square of that distance is proportional to the velocity that produced it. So that's how this is how these formulas and measurements and the fringes and all that were confirmed. So this hypothesis was that, again, there was a stationary ether, but it could be dragged with respect to the moving medium. And this is implemented in inertial navigation systems to this day. The ionization of the laser in the chamber creates a preferred direction for the gas flow that has to be compensated for to make sure that everything is zeroed out before they can start to get their readings. So this equation holds true to this day, and it was derived in the 1800s under the premise of an elastic ether and the density of ether in a transparent medium being proportional to the square of that refractive index. All right, so quick recap here on that now that we understand what they were putting forward with their measurements. We have here an experiment by Hoek where he was using an interferometer where light was being split through a tube that was half filled with water. And what he was going to do here was align this interferometer parallel and perpendicular to the plane of motion of Earth as it goes around the sun throughout the day. And he was going to take the difference in the speed of light as it goes through air and water, assuming Fresnel drag, and measure the difference there, which should correspond to a shift in the fringes of 30 kilometers a second if this water is carrying that 30 kilometer velocity potential. What he measured was that there was no change, i.e. that the water is stationary, and they were all under the illusion, because they had been doing these experiments in the first order that were yielding quote unquote null results. So the way that they were interpreting it was that there was somehow a first order ether effect that was canceling out the ability to measure motion in the first order. And so as they start to move away from that, we'll take a look at Michelson-Morley. But before we do that, there's two more where they tried to measure the velocity of Earth in the first order. So the second one following up with that was Klinkerfuse, who took a zenith-mounted telescope, filled it with turpentine, and said that the refractive index slowing light down changed the angle. It made the angle increase to the tune of 6 arc seconds, or by 6 arc seconds. So what he was saying with that was that, motion is a real effect. That was the premise of his experiment, irrespective of any motion of the ether or anything like that, which he explicitly lays out in his premise that, motion is a real effect. If this is true, then there's going to be this angle will increase. He says that he measured the angle. So Airy came along and was like, oh, okay, bet. Let me check and see if that's true. So he had a zenith mount telescope built, tested it with water, double spirit level here so we could make sure it's level, micrometer, wire, grid, so he could measure the angular size of the star and the position. And then he could rotate this 180 degrees on its spindle to take differentials from that to make sure that everything was as accurate as possible. What he concluded was that there was no change in aberration. It was the same. So if that's true, then that means that the aberration, the light, is already coming in at that angle with respect to a stationary Earth. And a quick recap of why this is important. Red, how am I doing on time, sir? A quick recap on why this is important is because what was at stake at the beginning, what was asserted was Kepler's laws and Newtonian dynamics, because you can derive
quickly, 6 minutes, 45 seconds.
Okay, thank you, sir. So what was asserted before was that Kepler's laws and Newton's laws are interlinked. You can derive one from the other. And Kepler's law says that the square of the periodicity of the orbital period of a planet is proportional to the cube of its semi-major axis, meaning it gives a length. It's basically giving dimensions to the orbital period. And then with Newton's laws, you can derive GMM over R squared, which gives the gravitational potential relationship with respect to the mass of the two bodies, and basically gives the same exact result. Now, the thing is that the mass of the sun is so big when you're doing calculations within the solar system, the mass essentially cancels out for everything. And you could use, once that cancels out, it just becomes a ratio of constants again over the periodicity, which is the basic premise of the equation. So you really can't definitively say for sure that just because these equations give the correct position, they're just based off of empirical observation. And because the dynamic equation falls off to a ratio of periodicity, it's not really as meaningful as it might be asserted. So these were hugely significant tests that were done that were supposed to give physical measurements of the movement of Earth. But again, they were saying like, okay, well, maybe there was maybe the ether, maybe for some reason we can't measure it to the first order. So insert 1887, we have the boys Michelson and Morley come through, and these guys design an apparatus where the light completes a back and forth trip such that their theory was that, okay, the first order canceling effect that the ether is having is going to be removed, and we'll catch the second order drift, and that will give us the 30 kilometers a second that we're looking at. So here we're going to read from the beginning of their paper where they talk about the two theories of light at the beginning. So one was the emission theory. One was basically light was a little ballistic projectile. And here they were multiplying by the refractive index, which makes the light accelerate. They predicted a smaller angle, which is not what's measured. The undulatory theory came along. So basically the wave theory of light. And this was compatible with Snell's law, and you divide by the refractive index, so it's slowing the light down. This makes the correct predictions, agrees with experiment. So Michelson goes on to say here that in order to maintain that the Earth is in motion with respect to these experiments and the new understanding of how we should calculate how light behaves, you have to make the absurd hypothesis that somehow ether becomes dislodged in the telescope and it carries light in the opposite direction to the tune of the Earth's velocity, or you have to accept that the light accelerates in water, which is obviously, a violation of conservation laws, and so no one's going to accept that. So he goes on to do the derivation here for how much he predicts the fringe shift should be, and this is based on the light path that light has to, or the distance light has to traverse across the interferometer, times the velocity squared over c squared, which is Earth's velocity. So basically how much the fringe is going to change when it's parallel and perpendicular to this plane of motion here. And what they measured was just over one fringe, which corresponds to a velocity of about 6 to 8 kilometers a second. You can call it 7 for the difference. Now the dotted line here is the theoretical predicted amount, which is it's the predicted amount of what it should have been. So, they were 4 fringes off to make their final measurement there for the full 30 kilometers a second. So they end up rounding this down to 0. And that's where relativity comes through and says, hey, we're going to say link contraction and time dilation happened on this back end of the second order effects. And that's why you can't measure it, because we don't even claim that there's going to be a first order effect. Now, why is this an issue? Well, all the explanations that are put forward to answer aberration, to keep aberration a valid measurement while rejecting other ones, the 6 kilometers, 7 kilometers is too big, right? But it's too small for Kepler, but it's too big to be experimental error. So to try and use any of these theories to explain it, you would run into contradictions here. Oops. And the only way the one that doesn't run into contradictions is the alpha model, which is the absolute lab frame and flexible ether. So the lab frame is fixed, stationary, absolute, and the ether is flexible and dynamic and moves. That's what's producing the measurements with respect to a stationary Earth. So here we have quotes from Michelson at the end talking about how the proportional ratio of the fringes are, exact to the velocity. And therefore, if we use these velocities, you wouldn't be able to make any explanations unless we round these down to 0, which is exactly what Einstein does. That's why he comes in with his 1905 paper and explicitly removes the ether, even though he's using the same framework as Lorentz and Voigt, who are describing the timing and spacing of waves with respect to an elastic medium. So Einstein makes it clear here to say that the introduction of luminiferous ether will be superfluous, in as much as the theory developed here will not require an absolutely stationary space, provide with special properties, nor will it assign velocity vectors to a point empty space where electromagnetic processes took place, which will be important to come back to later. So remember this part. And again, some people say, well, he introduced ether with the general theory and it's back again. Well, that's not necessarily true. He introduced it as a fabrical concept that has no physical meaning and should have no properties associated with it, and explicitly says here in 1922 that if you want the ether back, you can think of it, that's cool. But if you try to associate velocity to it, then you can't do that. Don't do that. So he explicitly removes the implication of all motion being relative to an ether. So that's why they can't bring an ether back, or there can't be any new theories, because every theory directly implies
60
Earth's
seconds.
velocity. Thank you, sir. Each theory would end up implicating Earth's velocity once you make the logical deduction that if you are surrounded by a medium, all motion in that medium is relative to that medium. Similarly to how sonars in the ocean work with submarines. So submarines use a range measurement equation using the speed of sound in water, and they use timing intervals to derive the distance. Nobody would argue that the speed of sound is constant. It's measured relative to the velocity of the receiver, and that is what is producing the accurate measurements. So the same exact concept would apply if there's an ether, and Einstein is explicitly here to remove that. This is why this is so important to acknowledge. Thank you. I yield the rest of my time.
All right, with about 13 seconds left. All right, thank you very much. And now I will give 15 minutes to Astronomy Live. Astronomy Live, go ahead and pull up your presentation if you have one. Once it's there, I will start your timer.
Okay.
All right, there we go. Okay, so your presentation is now showing, and your 15 minutes starts in 3, 2, 1, go.
All right, thank you so much. I'm Astronomy Live. I'm going to be talking tonight about stellar aberration and why Aries failure happened. So Alan already did me the favor of covering a lot of the basics. I'm going to skim over some of the historical details that are not in contention, like the fact that James Bradley first observed stellar aberration and came up with the idea for it when he found it didn't fit with what he was looking for, which was parallax, when he was observing Gamma Draconis. He was said to have had an epiphany about this motion being similar to what he saw happening with a flag blowing in the wind on a boat, and when the boat would change course, the flag would seem to change course to fit that. So stellar aberration, as mentioned, shows a deflection in the apparent position of a star due to Earth's orbit around the sun. So over the course of the year, it will change depending on where Earth is in its orbit. So in a 24-hour period, you can see what the sky looks like with a map of stellar aberration. The legend in the top right corner of each window shows stellar aberration in right ascension on the x-axis and aberration in declination, positive and negative, on the y-axis. And over the course of 24 hours, you can see how different parts of the sky are experiencing different amounts and different directions of aberration in right ascension and declination coordinates. And then over the course of a 1-year period, you can see how that effect follows our orbit around the sun. So I've had to use stellar aberration myself in accounting for where my telescope is pointing. So I've written software for tracking rockets and satellites, and I've created planetarium style software that calculates for stellar aberration so that when I map the pointing of the telescope on multiple stars, it lands on the targets that I'm going to, like you see in that left window, just perfectly. And the only way I can do that is by counting for everything, including precession and aberration. And in doing this, I can track objects at high velocity in the sky. So we have the Chinese space station on the left, and we have the Fram 2 Dragon on the right in broad daylight. And the only way you can catch something like that in broad daylight with no ability to lock on with it in a viewfinder camera is you have to hit it with accuracy with your telescope. So you have to account for aberration when aligning on the stars prior to tracking your target. So again, going over some historical aspects briefly here, Roger Boscovich was a Jesuit priest who lived from 1711 to 1787. And during that period of time, in the first part of his life, the Catholics had a ban on considering Earth to be in motion, which was finally lifted in 1757 by Pope Benedict XIV. So in 1742, he argued that the stars move in a manner that produces the stellar aberration in a revision to tectonic geocentrism. And in 1746, he described this motion being relative and keeping Earth centered in order to keep Earth from moving, specifically for religious reasons. But when the ban was lifted in 1757, he came around to the idea that this was actually due to Earth moving, not the stars. But in 1766, he suggested the use of a water-filled telescope to observe a change in the amount of stellar aberration. And in the 1780s, he even suggested that you could actually use a terrestrial light source and not even have to bother with pointing at a star. But attempts were made, and poor quality materials resulted in technical failures to try this between the years of about 1784 and 1786. Now, Boscovich's expectation was actually to see less aberration in a water-filled telescope, not more, due to his understanding of emission theory, which Alan alluded to, where water would be accelerating light instead of decelerating it. So he actually expected to see less aberration, not greater. But even the contemporaries of his time dismissed his expectation and expected that the telescope would produce no change if it was filled with water, even if Earth was moving. In 1861, Lorenzo Respighi conducts Boscovich's proposed terrestrial aberration test with a water-filled telescope and finds no effect of the telescope's orientation relative to Earth's orbit on the terrestrial targets. And then we come to Wilhelm Klinkerfues, and we see that he actually expected that it's possible that changing thicknesses of lenses over time is producing a discrepancy in the amount of stellar aberration. He was noticing that earlier determinations of the constant of stellar aberration, which decades earlier had been measured at 20.255 arc seconds, were a little bit lower than more recent determinations at 20.445, for example. And so in 1867, he uses a water-filled telescope that was actually only partially water-filled with an 8-inch column of water inside of it to see if there's a change in the amount of stellar aberration. His hypothesis was that the discrepancies that were starting to be seen in the amount of the constant of stellar aberration was due to the fact that over time, as lenses get bigger in telescopes, they also get thicker, and that was causing a change in the amount of aberration that was being perceived on the other end of that. So again, his inspiration for this was in observing the discrepancies of values of the aberration constant at the time, and knowing that the earlier determinations were made decades ago, and in some cases by people who weren't even alive anymore. And now with larger, newer telescopes, perhaps the thicker lenses were causing a systemic issue, and this was something that could be interrogated by filling the telescope with water in order to increase this effect even further. He ultimately came up with a formula that he predicted based on his observations. He saw what he thought was an increase in stellar aberration and published the formula that this change in aberration was equal to the square of the refractive index minus 1 times the aberration. So then we come to George Airy, and he lived from 1801 to 1892. And in 1871, he published his report of the non-reproducibility of the Klinkerfues results. He used a water-filled telescope that was basically completely filled with water across a length of 35.3 inches. And his observations determined no effect of a water-filled telescope on the amount of aberration. And Klinkerfues, his results actually were a surprise to Airy's. He recognized that this had serious ramifications for the undulatory theory of light, the theory that the light was in an ether, and that this would have some serious ramifications, not only for measuring the positions of stars and measuring the constant of aberration, but on the measurement and actually detection of ether itself. So he built this water-filled telescope, or he commissioned it for construction. Alan already showed this. And at the bottom in figure 7, this is where the micrometer is, where there's wires crisscrossing, and this is how they measure the transit of the star and its distance from the zenith. So he made these measurements and actually made them about 6 months apart, and saw no effect of the water-filled telescope. His results ended up producing a mean deviation of about 0.37 arc seconds plus or minus, indistinguishable statistically from 0, and quite in contrast to the prediction of plus or minus 15 arc seconds. So again, based on the fact that his telescope was fully filled with water, and based on the refractive index of water of 1.33, if you take the square of that minus 1, times the actual amount of aberration of Gamma Draconis, which was 19.36 arc seconds, we get 14.89. So about 15 arc seconds is what he expected based on the Klinkerfues hypothesis. But he found it untenable because his results showed basically no effect. So Airy's result was specifically testing whether or not ether would cause a difference in the change of stellar aberration. He wasn't doubting the fact that Earth was in motion. That was already determined by the presence of aberration itself. But what this would have meant had he found a change in the amount of stellar aberration was that the analogy of looking at rain as you're moving in a vehicle and seeing that rain appearing to come at you at an angle more straight at you as you move towards into the rain, that analogy starts to break down. If this is light entrained in ether, and if that ether is being affected by the motion of the Earth and the telescope in a way that was not expected, then that analogy starts to break down at that point. So I have a question for Alan, and my question is simply, what did Airy actually observe with his water-filled telescope? Which of these illustrations below most closely represents what Airy actually observed with the light hitting his water-filled telescope? Is it A, B, or C, or is it something else? And with that, I yield the rest of my time, and that is the end of my introduction. Thank you very much.
All right, thank you. With 5 minutes and 24 seconds to spare. Good job. All right, so now we are going to get into the open discussion segment. So Alan, I'm going to give it to you. Since Astronomy Live left off with a question, I think it only makes sense to give it to you, so you can either answer it or ask a follow-up clarifying question, and then we will just go from there. So Alan, take it away.
Sure. B, the angle stayed the same, or the aberration stayed the same.
Okay, so that is incorrect. This is showing the incident light reaching the water-filled telescope. B is not actually what we see. I'm going to go ahead and present a different presentation, so stand by. Okay, and let me know when you can see my screen.
And we can see it.
Okay, so let's go over what was happening with the water-filled telescope. So let's explain aberration from a frame of reference where the telescope is moving. We have our simple telescope diagram here. We're going to treat this as a simple 2D model, okay? So the telescope is going to be moving along the x-axis to the right as a photon of light from a star enters the tube and proceeds down towards the bottom of the tube. By the time that the photon has reached the bottom of the tube, it has reached point B. It entered at point A. So during that period of time, the telescope has moved horizontally by a factor we will call xt. And the time it took for the light to reach position B can simply be defined as t equals the length of the telescope L over the speed of light c. So if we substitute L over c for t in the xt equals vt equation of xt equaling the velocity of the telescope times the time it took to move, we get vt equals vl over c. So point B is to the left of point A where the photon entered the telescope, and this amount is something we can define as xa minus xb, which equals vt, which also equals vl over c. The angle of the light ray relative to the vertical can be expressed, and this is actually equal to xa minus xb over L, the length of the telescope. And since the angle is small, we can express this as to the first order as xa minus xb over L, which equals v over c. And this angle is the aberration angle in an air-filled telescope as normal. Now, to the figure I showed you a moment ago, that is the incident light reaching the telescope. It will experience refraction as it hits the water inside the telescope. Now, as Airy was performing his observations, this was an instrument that was pointed at the zenith, not tracking the star, but looking at how the star is moving and how far it is from 90 degrees above the horizon. So that star I've labeled here as a diagram as a red star moving from one side to the other in a period of delta t, and he's measuring it with a micrometer at the bottom of the telescope, and the distance that star covers there, we're calling delta x, how far the star moved across the wires of the micrometer. But as you can see, there's refraction at play here, so we have to correct for this, and Airy did this explicitly. He took the length of the telescope, 35.3 inches, as mentioned previously, and divided this by the refractive index of the water, 1.336 by his calculation. So L prime is equal to L divided by the refractive index N. And the angle he's measuring can be corrected for with the micrometer divided by L prime, and that gives us the angle of the star as it was moving prior to being refracted by the water inside the telescope. So now we have a water-filled telescope. What's happening here? So as Alan pointed out, you have the Fresnel drag equation, and the light is partially dragged in this model by a formula of v times 1 minus 1 over the refractive index squared. And the time for the light to reach position B in this water-filled telescope is now increased by the presence of the water, so t equals n times L over c. The telescope moves to the right during this time by xt equals vt, and we substitute nL over c for t, so we get xt equals vt equals vl n over c, and during this time, the light is dragged to the right by the Fresnel drag factor of xl equals v times 1, in parentheses 1 minus 1 over the refractive index squared times t. And now we substitute the NL over C for T, and we get XL equals V times 1 in parentheses minus 1 over the square of the refractive index times the NL over C. Now, we can simplify this to N minus 1 over N times VL over C. The distance between A and B is, once again, therefore, XA minus XB, which is equal to XT minus XL. So now let's substitute the formulas we just came up with for XT and XL into this equation. So VLN over C is now minus N minus 1 over N times VL over C. Then if we put that into the parentheses, we get VLN over C minus, in parentheses, VLN over C minus VL over NC. Now, if we put that minus N and multiply minus 1 into those factors in the parentheses, we get VLN over C minus VLN over C. Obviously, that's going to cancel, plus VL over NC, so it simply equals VL over NC. The aberration in the water angle can be expressed as XA minus XB over L. And now we substitute that equation in for XA minus XB. And so XA over XBL over L now equals VL over NCL. And this, again, the L's cancel, so it equals V over CN. The aberration in the air was equal to V over C, so we substitute that angle in, and we get that the angle in the water is simply equal to the angle in the air over the refractive index, which is literally just Snell's law. The light will follow normal refraction through the water, whether it's at rest or moving. This is the prediction from even just a simple Fresnel drag equation. And we see that if we actually plug in the numbers here, and we look at the amount of refraction expected, and this is in this case based on mine and Red's own measurement of the distance of the sun, and we look at the aberration in the water, we get an angle of about 0.00429 degrees, which is exactly the same as what Snell's law predicts, even if you had a stationary water-filled telescope. In arc seconds, that's about 15.44, same as Snell's law. And then when the light leaves the telescope, it is back to an angle of 20.548 arc seconds, exactly the same as Snell's law. So once again, the results match Snell's law. It's all just Snell's law. So we see that actually, even if you use Fresnel drag, you still get a prediction that you wouldn't expect to see any difference in aberration, which is why it was such a shock to Airy that this was reported, and his efforts then to confirm these results where he found them to be non-reproducible. All right.
All right, so super long roundabout way to say that the telescope is angled vertically, right? The starlight's coming in, there's no deviation. So instead of having it come off to the side or whatever to show that it's coming in, or that there was no deviation, it already comes in at that angle, it would just be vertical. They didn't measure an angle increase. Applying Fresnel drag, right? So that you're applying it to laterally. It's only been measured when the motion is parallel, or when it's going with the flow or against it, not when it's perpendicular to it. So like how it's going to translate all that. But the main point of this is that there's only two variables in the V over C equation, right? For this angle, for this tangent angle to be derived. And it's the speed of light and the velocity of Earth. When you change one of those variables, you get an angle increase. You do not get a same angle. That's completely preposterous, right?
Well, I just went through all the math, and the math actually predicts you will literally get the same angle that you will get, just what Snell's law would predict for a stationary telescope. It is identical for a moving telescope.
So then you can't claim mutual exclusivity then, right? Because the whole point of this, and especially starting with the primary citation you started with, was that this can only be explained by the heliocentric model. Are you yielding to that and saying that you don't have mutually exclusive proof that the Earth is in motion?
If you're referring specifically to Airy's results in a water-filled telescope, then no, there's nothing exclusive about the fact that the water doesn't change the angle. But in terms of stellar aberration, yes, stellar aberration itself is exclusive to the heliocentric model with the Earth moving around the sun. We can vary something.
Not at all.
Hold on, don't interrupt me. We can vary something else beyond just sticking water in a telescope to see which one's true. Alan, let me ask you, let me actually screen share. Yeah, this will make it easier if I screen share this. Okay, so here is the equation for stellar aberration in the ecliptic coordinate system. So because stellar aberration is related to Earth's orbit around the sun, it's simplest in the ecliptic coordinate system. Negative 20.5 times the cosine of the longitude, the ecliptic longitude of the sun, minus the ecliptic longitude of your star, times the cosine of the ecliptic latitude of the star, so on and so forth. So let me ask you a question, Alan. With these two equations in mind, what points in the sky show no stellar aberration? I can't hear Alan.
Alan, we can't hear you.
Oh, that's not my premise, that there wouldn't be no stellar aberration. My you're saying that this measurement of aberration in air is mutually exclusive. I'm saying that it's not. It's either one would produce the same effect. A measurement is just kinematics. That's just relative motion. It could be the sky in motion, or it could be the earth in motion producing the same effect, or there could be a medium between us and the sky producing the same effect. This was the reason that they did the experiments in the first place, to try and figure out, to get a first order measurement of the earth through space, because just the observation alone, an empirical observation alone, can't tell you the correctness of it. You can have a mathematical model, you can have fancy ratios like Kepler's and Newtonian dynamics, but the reason they test, the reason they continue, is because they need a way to relate that ratio in an actual measurement. So we have a measurement, right? But we have no independent variable manipulation here until we add water to a telescope to change the speed of light and the ratio.
Okay, so I don't think you understood my question. It's not a measurement. This is the equation, the prediction for stellar aberration. So what points on the sky do these two equations predict? You will see zero stellar aberration of your target.
I don't think you understand that the cause of stellar aberration is what the purpose of this debate is about. I don't care what these equations say, right? We're talking about the cause of stellar aberration, right? You're saying that based off of just the observation alone, you know that the cause is Earth's motion. I'm telling you that's kinematics. That's relative motion. It could go either way. We need to introduce a manipulation of one of the variables in the equation, and the only one that we can manipulate is the speed of light by introducing water into the telescope.
Well, it turns out that's not the only thing we can manipulate, but we'll get there. I'm asking you a question about what these two equations predict. These two equations predict that you will not see any stellar aberration at 2 points in the sky. What are those points?
If you could get to the punchline, I anxiously await. I don't know. You go ahead.
I mean, it's pretty simple.
Okay. Are you gonna?
So Alan, what happens if you plug in 90 degrees and 270 degrees from Earth's longitude, sun's ecliptic longitude into these equations?
What happens when you make your point?
Okay, no need for that. But the answer is 0, right? So if you plug in 90 or 270 to these equations for the ecliptic longitude of the star, you get 0, right? Now why is that?
Did you say you were going to make a point?
Oh, we're getting there, but I'm just laying the groundwork here, okay? Why is that? Here, let's hang on, let me get to my PowerPoint here. Let's go to the next slide, okay? So again, this is my render of how much stellar aberration is expected throughout the sky over the course of a year, playing on loop. There's 2 points here that are fairly neutral looking colors that are 90, 180 degrees separated, right? So if you were able to speed up the telescope, if you were able to look at a star somewhere, maybe somewhere just off of the velocity vector, which is what that 90 and 270 represent, the Earth's velocity vector in its orbit, right? If you were able to point your telescope somewhere along generally the velocity vector, but instead of it taking 6 months to get around to the other side, what if we could alter a variable so that it only takes maybe half an hour, maybe 45 minutes? What do you think we would see? What would we observe if you looked at a star and you looked at all the other stars right next to it in a very tight space, and you could accelerate all this process up to take just about 30 minutes, 45 minutes? What would you see?
What would we see if we got to the point?
So is that you saying you don't know what you would see?
I don't know what we would see. Please tell us. Enlighten us.
Okay. All right, great. So you accelerate your telescope, and what you see is along the velocity vector, the stars appear to contract. Away from the velocity vector, the stars appear to spread out from each other. So it so happens there is a telescope that we've altered its velocity. It's not just traveling at Earth's orbital velocity, it's traveling in Earth's orbit at about 7.5 kilometers a second, the Hubble Space Telescope. Now, I've personally observed the Hubble Space Telescope, and I've personally verified that it is pointing at the objects that it is scheduled to observe when it is scheduled to observe them. So I've confirmed using a simulation pointing a simulated Hubble at the same coordinates and comparing the simulation to what I observed Hubble to be doing from my own telescope at the same coordinates on Earth. And sure enough, Hubble's attitude matches. I've done this multiple times, and every time it's a match. Hubble is pointing at the objects it says it is and taking pictures. And so if we look at those pictures on a global scale, the full frame of the picture, this is what we see when we look at individual raw pictures. All the little points, all the little dashes, that's radiation from Hubble being outside of Earth's atmosphere and unshielded from a certain degree of radiation in space. And what you see, you don't see a whole lot of change there. But if you zoom in and you look very carefully, what I'm going to do is I'm going to crop in on the 4 corners of this picture, and we're going to look at them and see what's happening. And what we see is stellar aberration happening in real time. These pictures are 30 minutes apart on opposite sides of Hubble's orbit, one generally along the velocity vector and one away from the velocity vector. And this is causing the entire image to change in scale. So you can actually see it in real time. We've now altered the variable. We've altered the velocity of the telescope, and we see stellar aberration altering and changing as expected.
Oh. Again, do you think that the relative motion of kinematic, can I screen share real quick so we can clear up a definition real quick?
Sure thing.
We're
Just let me know
running
when it's up.
Yep, should be coming up now. We're running into an issue where your conclusion is my premise.
All right, it's up.
Thank you, sir. All right, so we have here from Fundamentals of Physics, Mechanics, Relativity, and Thermodynamics from Shankar. Quick definition on kinematics, right? What you were just describing was measurements of relative motion. Not introducing anything that's changing the relative variable, i.e. the speed of light in the V over C equation that we're looking for. The very premise of what we're testing, right? So anyway, you're just, we're also moving, so it makes it more different. Nope. Kinematics and dynamics. Kinematics is the complete description of the present. It is a list of what you know about the system right now. For example, we're talking about a piece of chalk and you want to know where it is and how fast it's moving. Dynamics tells us why the chalk goes up, why it comes down. It comes down due to the force of gravity. In kinematics, you don't ask the questions behind anything. It simply describes things the way they are. And the dynamics tells you how it is, the description of why things change with time. So the big important distinction here, I can go ahead and stop screen sharing now, right? Everything you just listed is kinematics, right? When we're looking at a telescope, we're assuming the Earth is in motion, right? We have speed of light. We have water to slow the light down. That's going to produce an angle change. Now, you were familiar with Klinker-Fuse's work. You quoted from him, so I assume you read his premise, like explicitly talking about how his hypothesis is independent of any ether theories regarding the flow, for whether it be Fizeau or static or in motion, right? Because the effect of motion is a real physical effect, and when you introduce light, when you introduce a medium to slow the light down, the distance that Earth can travel increases. There has to be an angle increase. That's the fundamental bottom logic of that. Now, when you get into the quote unquote relativistic explanation of this, right, which is where you do a transformation to the position of the sun, taking the stationary water with you and all the information from that to the sun to predict no change. That's not mutually exclusive. That's taking the classical framework and repackaging it and saying that due to the second order transformation, we predict no change. That's absurd.
Alan, in the equation V over C, what is V?
Velocity.
Mm-hmm. And what happens when you put your telescope in orbit? Is V constant?
You're no longer measuring the V of the Earth, dude. That's the whole point of this, right? What you're showing is just more relative motion of the same thing. It's not going to give you anything different. That's the premise of this.
What does V become when you put your telescope in orbit?
C plus V.
C plus V? Ooh, that's one fast telescope. No, my friend, it becomes the velocity of the telescope plus the velocity of Earth going around the sun, right? So the velocity of the telescope is varying on a time scale now of just a few tens of minutes. Why do we see aberration changing on a time scale of a few tens of minutes when we put our telescope in orbit?
Relative motion is still making the same measurement. The variable you have to manipulate, right? The velocity you have to manipulate in this is the light variable. The relative motion, taking the relative motion picture is not going to tell you anything different.
So we've manipulated the variable. We just didn't manipulate the one you wanted. We manipulated V. The velocity of the telescope.
And why do you think it comes out the same? Because it can't tell you anything different unless you
it comes out the same?
You just told me it comes out to aberration.
Astronomy Live, you are muted.
Yeah, sorry, I wanted to screen share again.
Oh, okay, hang on. Okay, there you go.
Yeah, so it clearly isn't coming out the same. It's quite different. On a time scale of 30 minutes, the aberration is changing there enough that we can actually see it in the picture. So we've manipulated V, and we're seeing a change in the aberration.
Can I ask you a question?
Sure.
If the Earth is stationary, right, and the stars are moving around us, and you had a satellite in orbit around us, you would see this exact same thing. That is my point. This does not tell us anything different or unique about the measurement.
Oh, so you're saying it's around Earth, and the whole universe is doing this, and the stars are just doing these little circles to fool us into thinking that it's aberration.
I will easily grant you that premise for the purpose of the debate. We're not discussing the shape here. We're discussing mutually exclusive proof of motion, which you have yet to provide.
Okay, so again, we've got Hubble here. We see aberration changing under Hubble's velocity, right? So if the stars are just exhibiting a baseline of aberration that we observe here on Earth to fool us, and it's not actually caused by Earth going around the sun, and yet when we accelerate the telescope a bit to a fraction of Earth's orbital velocity, we see this change in aberration. Well, okay, let's get to the next bit. So Hubble isn't the only thing in space, right? So I'm going to stop sharing for a moment.
Yo, are you about to present more kinematics?
I'm about to present proof that aberration is dependent on Earth's position in its orbit around the sun. So let's go ahead and present this. So yeah, we have here something moving through the frame. So this was actually a comet that I discovered back in 2016. At the time, it was designated P2016J3 stereo. I was using stereo spacecraft images on the opposite side of the solar system when both the comet and the stereo spacecraft were opposite on the opposite side of the solar system from us here on Earth. So this comet was observed and discovered by me. I'm the official discoverer of this comet before it was seen from Earth. And in fact, it was indeed later confirmed from the ground, from Earth, by observations made by both professionals and amateurs. So here's the page for this comet on the Minor Planet Center website, and here are the list of observations. And as you can see, stereo has the monopoly on the initial observations of this comet. But years later, it was seen, and the position was measured from people on the ground, both professionals and amateurs alike. So this comet, I discovered it before it was seen from Earth, when both the comet and the spacecraft were on the opposite side of the solar system. Now, if we look at the comet's position in those images, and we account for the amount of aberration we expect stereo should have on the opposite side of the solar system from us, we see that it matches the comet's position in the images. But if I calculate the amount of aberration that should have been seen, assuming it's just something that we see on Earth that we misattribute to being aberration due to our orbital velocity, well, then in the red circle, that doesn't match the observation nearly as well. So again, I took the coordinates of the comet and I calculated for myself what the aberration correction should be, again, if this were seen from Earth. But that turned out to be quite wrong, and we see a different amount of aberration thanks to stereo being on the opposite side of the solar system.
Does the aberration angle give a 30 kilometers a second ratio?
Yeah, it's the same aberration constant because stereo is in a very Earth-like orbit around the sun. But the problem is,
fantastic.
The problem is the magnitude is exactly flipped. It's on the opposite side of the solar system.
Oh, no
on the
way.
opposite side of the sun from.
Oh, no way. All right, cool. Check this out. Can I present?
Yep. Let me know when you're presenting.
Oh. Okay. So when I asked for mutually exclusive evidence, right, and measurements, what I got was relative motion, and that's it. Just kinematics. Just kinematics. So we're going to do a quick review of actual experiments involving the wavelength of light and relative motion. It turns out that you can measure motion down to the wavelength of light so long as the distance traversed is greater than the wavelength being used to measure the light. So we have the most accurate and natural form of measurement known to man to measure the velocity of anything through space. Now, what these gentlemen did with this power, as they started discovering it in the 1800s, was that they could do experiments to measure the velocity of Earth through space, right? They could actually manipulate variables. They could introduce water. They could slow light down. They could change the angle in which they would be parallel or perpendicular to the plane of motion with respect to the time of day following sidereal time. And they could plot the minimum and maximum speed of light throughout the day and do a Fourier analysis using sidereal time to see if that makes a sine wave or not. And what they found was it does. So this, to answer why the measurements differ corresponding to the position of the sun throughout the year and the day for sidereal time, our premise is that there is an ether wind that gets measured, or that has been measured, that shows sidereal fluctuations. So it measures sidereal time. When they talk about we measuring Earth rotation with a gyroscope, with a ring laser gyro, all this stuff, those are all sidereal measurements of ether wind. Those are interferometers measuring sidereal time, right? And then also, in addition to that, what was found, but this is largely suppressed, is that there's an annual variation that corresponds to the position of the sun on the equinoxes. So the position of the sun and the speed of light changing things, how we interpret it on the ground, is exactly, it's no issue for us, right? Where it becomes an issue is right here at the beginning. This guy says that the speed of light has to be constant and the Earth has to also be in motion. So far, what we've looked at is that there's latitude-dependent variational speed of light that fluctuates with sidereal time and the position of the sun, just not to the magnitude that gives 30 kilometers a second. The only thing we have is a displacement angle when we're introducing no other independent variables to manipulate it other than moving faster around the Earth. When you actually take a measurement and manipulate the variables that matter, you don't get 30 kilometers a second at all.
But you do. And we've manipulated the variables. Again, literally, we've manipulated the velocity of the telescope, and it is very dynamic. And we can see that it has effects on the images. So clearly, it is a velocity-dependent aberration. And we can put the telescope on the other side of the sun, and we can see, oh, look, aberration looks like it should on that side of the solar system for that
Astronomy.
telescope being in that. Hold on.
Okay.
For the telescope being on the opposite side of its orbit. And we know it's at a certain velocity because we launched it off the Earth. We launched it into that solar orbit. That took quite a bit of kick to do. So we know its velocity, we know that it's traveling about 30 kilometers per second just on the opposite side of the sun. And because of that, the magnitude of the aberration is reversed. So we've manipulated the variables. We've manipulated the velocity, we've manipulated the position, and it matches up. Wouldn't you know it? So why would we then conclude that Earth isn't moving when we can literally put the telescope in motion, put it directly opposite Earth, and see what we would expect for that telescope to be moving, which we know it's moving because we launched it?
Well, for one, it wouldn't be mutually exclusive because the relative motion between you and the starlight, right, could be producing the effect to the same thing. That's the point of introducing water and manipulating the speed of light, because the Earth physically has to move out from underneath it. What you're presenting is not mutually exclusive. Again, what I was saying earlier, real quick, was that there's a east-west differential or bias that's produced in the speed of light, right? That in combination with how the sun is affecting the measurements produce this aberration effect. This is what the interferometric measurements are corresponding to with sidereal and annual solar positions, right? But just not to the magnitude of what is required. Now, if the Earth were actually moving, they would have those corresponding measurements. You don't. You only have measurements where you can't tell if the medium between you and the light is also moving. That's why I say that these aren't mutually exclusive, and you have to do something where we're manipulating the speed of light, because the relative motion between the two tells us nothing. Go ahead.
Sorry. I can't help but notice you keep bringing up Michelson-Morley interferometry, which is a very interesting subject, and I would, be happy to discuss that at a later time. The subject of the debate tonight is stellar aberration and Airy's failure. Okay, so we've manipulated the velocity of the telescope, we've manipulated the position of the telescope, and we see aberration occurring. Whether we increase the velocity of the telescope, we see aberration changing there, or we put the telescope on the other side of the solar system and we see aberration on the other side of the solar system, which is what you saw on Earth 6 months ago, but Earth's now moved, and well, so has that telescope that you launched from Earth. So again, I ask you, you've manipulated the variables here, and we see the expected change. Why would I ever conclude that Earth isn't moving when I know for a fact Stereo's moving, the comet's moving? We launched the Stereo spacecraft, it saw the comet on the other side of the solar system, and it saw the amount of aberration that we would expect on the other side of the solar system with a totally different magnitude than we see on Earth.
Alan, but before you answer, just hold that thought for a second. I would like to give a warning that I'm going to be posting a poll in the live chat. And to make sure it's fair, I think it's prudent to give that warning because, Alan, I do believe you are restreaming this somewhere else, which is fine. But if your audience wishes to participate in this poll that will be posted at the end of the debate, this would be a time to give them a link so that they can arrive, subscribe, wait 5 minutes, and then they'll be able to participate. I just want to make sure that this poll is fair when it is time to do that poll. So with that, Alan, please continue.
Cool, no worries. Okay, so as stated from the citations, right, we're looking for mutually exclusive. When you're proposing a measurement where the medium between you and the light isn't being manipulated, you're not proposing anything mutually exclusive. And I kind of see why, because all of your, am I screen sharing right now? Is it working?
Yes, that is correct. I caught it in time.
Okay, gotcha, thank you. So all of the measurements are, that you're proposing, right, what you need to be manipulating is the medium between you and the light. That is the relevant portion of this. And the reason I keep going to Michelson-Morley, and I'll stop since you requested, but the reason I kept doing it was because we need to, just stuck on aberration, if you're not going to acknowledge mutual exclusivity in that regard, then we would have to move on to like a secondary thing to falsify. So I was trying to get around to, like, if you wanted to talk relativity, because this obviously in the citation says that it depends on the constancy of the speed of light. So if you wanted to get into that a little bit, because it is dependent, in both models or whatever. So it is related, but if you don't want to talk about it, I'll ease up off of it. But do you understand what I'm saying when I'm like, I get that the relative motion, like, all good, but we need to manipulate the medium between us and the light because there could be another variable in between there that could be producing the measurement. That's all I'm saying.
We already went over, I'll go over it again, but we already went over what we expect to see when you manipulate the medium inside the telescope, and we expect to see no change. It's literally just going to be Snell's law. Okay, I'm not going to go over every line of the math again. I've already done it, but we expect to see no change. The same prediction for a stationary telescope with Snell's law as for a telescope that's moving at 30 kilometers per second with water filled inside of it. So that's not going to do anything for us, which is why I then moved on to show you what happens when you accelerate the telescope and change the velocity at play. We see the expected amount of change in aberration when we accelerate, or in actually 30 minutes now decelerate the telescope. It's going around the Earth. It's doing this. So first it's moving towards, it's moving away. It's cycling about every 45 minutes, one to the other. So in pictures 30 minutes apart, we see this change. And we've also seen the change when we put the telescope clear on the other side of the sun, and we look at stars and we look at, say, a comet that hasn't been discovered from Earth yet. We find out, oh, that's what the aberration is on. If you expect the camera to be on that side of the solar system, that's not what it is for Earth. So it's changed, and it's changed because we've accelerated that telescope to now orbit the sun differently than Earth and go around to the other side of the sun. So again, where would I conclude from that Earth isn't moving? Where's the evidence that Earth isn't moving? Because I have all this evidence here that shows Earth is in motion. In fact, when I change the motion by adding to it, by accelerating a telescope into orbit around the Earth, or I put the telescope clear on the other side of the solar system, I see velocity and orbit-dependent changes in aberration. So why would I then not conclude that aberration is an effect of the orbit around the sun?
Again, because you're not manipulating the variable between you and the light, you're just doing relative motion, which was my premise the whole time. Now, secondarily, there's something called velocity composition, and you're not following velocity composition if your aberration angle is producing the same exact angle in water as in air. That doesn't make any sense, right?
Oh,
the light slows down. The distance traveled has to increase. It's very simple. And in fact, relativistic velocity composition agrees with the classic velocity comp up to 2/10 millionths of a degree. So what you're proposing, right, this like, oh, the null comes from Snell's law, it actually doesn't. It comes from them doing a Lorentz transformation to the sun and claiming that the wavefront already comes in tilted because of the relative motion. It's like what you're proposing through the Snell's law predicting zero isn't even a canonized thing. It's like, it doesn't even make any sense.
No, that is the normal prediction. So here we have, you want to talk about relativistic composition of velocity. Here we have the prediction for the relativistic composition of velocity and Fresnel drag, and out to even 30 kilometers per second, if you could get water moving that fast in a lab, you still get a difference of the relativistic prediction of only just less than 1 meter per second compared to the Fresnel drag solution. So we can use the Fresnel drag solution for our purposes in this debate, and that's what I used in the math that I already presented to you. You accepted the Fresnel drag in your own presentation, and I showed you how that causes it to show no effect, no difference between a water-filled telescope and an air-filled telescope. So we don't expect there to be any difference in the amount of stellar aberration in a water-filled telescope, even on an Earth that's moving at about 30 kilometers per second. So we've already been over that. So now I've presented you with a telescope that's moving at a different velocity, and we see a different amount of aberration, and I put the telescope on the other side of the solar system. Well, not me personally, but NASA, and I used it to discover a comet before it was seen from Earth. So I know those images are good, I know those images are real, and we see a different amount of aberration than we see on Earth for those coordinates at that time. So again, I ask you, why would I conclude that Earth is not in motion from that set of evidence?
All right, so check it out, big dog. We have a ring laser interferometer moving at not relativistic speeds, right? It's just a laser ionizing gas in a chamber, and just that alone from the electric current is creating a preferred direction, which is causing Fresnel drag to have to be accounted for down to the basically like the nanometer, the wavelength, right? Now, what you're telling me is that when you put water in a telescope for something that's moving at 30 kilometers a second, you predicted that same Fresnel drag predicts zero, dude. That's completely contradictory. The only way that it would predict zero is if you took the rest frame and did a transformation and then reasserted that as if it was the actual way to look at it.
Okay, so again, am I still muted? No, I'm not muted. Okay, good. So
now we can hear you.
Okay, let me share my screen again.
Okay.
So once again, the difference between the water-filled telescope and the air-filled telescope is zero because it just all acts like Snell's law. Now, in this reference frame, the telescope is moving, and it's moving at 30 kilometers a second in my calculations, but it predicts no change in the amount of stellar aberration. That's precisely because of the Fresnel drag that I used in that equation, which is the same as the prediction, as the relativistic prediction to the first order. So yeah, it predicts no change for the water-filled telescope. So we have to change something else. That's why I presented you with the telescope that is moving at 7.5 kilometers per second and the telescope that's on the other side of the solar system moving at 30 kilometers a second. And we see changes in aberration there. Now, without going off topic and without trying to deflect to anything else, I ask you one more time, why would I conclude from the set of evidence I have presented you the idea that the Earth is not moving?
All right, because real quick, you have gone full circle. So in order to predict that Fresnel drag or any theory predicts a null, or predicts that there's no change, let me make this extra big so we can all see it here. All right, so this is from the beginning of the Michelson-Morley paper where he talks about the history of Aries and the implication here. So I'm just going to read from this so we can all understand what's going on here. The discovery of the aberration of light was soon followed by an explanation according to emission theory. So remember that ballistic theory we talked about that turned out to be incorrect because they were giving the wrong treatment to how light behaves in a medium. The effect was attributed to the simple composition of velocity of light with the velocity of Earth in its orbit. Now this is talking about the aberration effect where the tangent is equal to V over C, giving 30 kilometers a second. The difficulties in this apparently sufficient explanation were overlooked until after the explanation on the undulatory theory of light was proposed. So they ignored the incorrect treatment for the ballistic theory. But then when they got the undulatory theory down and Snell's law and accounted for everything correctly, light was a wave and that the angle would increase, They had a new problem. So this new explanation was that first as simple as the former, right? Why it's a wave instead of a ballistic, but it failed to account for the fact proved by experiment that aberration was unchanged. The aberration was unchanged when observations were made with a telescope filled with water. And what he's saying there, right? Remember, they've got this whole theory of like how there's this first order cancelization that's magically happening, right? And so the two theories that were put forward to answer this, there was three actually. One was Fresnel, and the other one was Stokes, and they were basically saying that the static ether that they believed in, was dislodged in the telescope, and it was carrying the light in the opposite direction of motion. And this is super important, which we're about to get to, right? Because this is what you're asserting, that there's a nullsy, and we're going to find out that that's an absurd hypothesis. Or if the tangent of aberration is to the ratio of the velocity of light, is to the velocity of Earth to the velocity of light, then the latter velocity in water is 3/4 the velocity in a vacuum, and the aberration observed with a water-filled telescope would be 4/3 its true value. It may be noted, and then here's a little disclaimer from Michelson. It may be noticed that most writers admit sufficiency of the explanation according to the emission theory of light, while in fact the difficulty is even greater according to the undulatory theory. For the emission theory, the velocity must be greater in the water telescope to therefore keep the aberration prediction to make it less. Hence, in order to reduce it to its true value, right, and its true value, they're assuming that there's some reason as to why they can't measure the first order change, which would be like 27 arc seconds, right? We make the absurd hypothesis that the motion of the water in the telescope carries the light in the opposite direction, right? What you're asserting is that for some reason, right, the light speed, this is where physics was at 1887, right? No one had an explanation for this. To this day, there's still no explanation. We're looking for mutually exclusive proof, and you're like, I changed the velocity and took a picture. Sorry, Charlie, you need to change the medium between you and the observation. If there's no mutually exclusive points or evidence, I'll let you get your last evidence or whatever thought, and we could kind of close out here because there isn't much of a debate to continue on.
Well, okay, so I already gave the full mathematical breakdown of why we expect no change in the water-filled telescope. I'm not hearing any contradiction of any of the mathematics I presented. I'm hearing appealing to Michelson-Morley, to other papers, but I'm not hearing any contradiction of the mathematics I presented, and I'm not hearing any explanation for the fact that I've manipulated the velocity variable and the position of the telescope to the other side of the solar system, and I see a corresponding change in aberration. I still never heard a response to why I should conclude from the evidence I presented tonight that the Earth is not in motion. I therefore conclude that the Earth is in motion.
Alan, we'll give you the last say before we get to a super chat question that we have, and then we're going to have a poll.
Cool. Well, I would like to thank you, Rez. You were an awesome moderator. Thank you for hosting this, Astronomy Live. Thank you for taking this debate. Much appreciated. Like I said earlier, this is one of my favorite subjects, and I don't often get a chance to have a full discussion on it. So much appreciated for your time. That's all I have to say really about it. We can move on.
All right, understood. So I have here a question from Icy Spin for $1.99. Thank you very much. Alan, how was Astronomy Live able to make his prediction?
Velocity composition? Non-relativistic velocity comp?
You want to just expand on that a bit?
Or aberration? It's just V over C. Was prediction.
All right, understood. And all right, the poll is...
Sorry to interrupt, Rez.
Go ahead.
I am full out of water. I'm going to go grab some more water, and I'll be right back.
Understood. Okay, so the poll is now up. If you remember, I gave a warning about this poll so that if Alan is restreaming this anywhere, his audience can come over and participate in this poll. Again, if you are not seeing it or don't have the ability to access that poll, that's because you need to subscribe to the channel and wait 5 minutes. I'm going to wait 5 more minutes for this poll to do its thing, and then I will give the results. And if afterwards, if you want to unsubscribe, that is totally fine with me. This is only to prevent spam and nothing else. Okay, so for £5 from Slicks666, it is a question for Alan. Alan, what practical work have you done to back up your claims?
I have a series of presentations documenting the history of interferometry and practical uses of ether and current technology such as GPS. It's all on my YouTube channel at @space_audits.
Understood. And I'm going to ask the same exact question to Astronomy Live. Astronomy Live, what practical work have you done to back up your claims?
Oh, great. Well, let's see. I've discovered Comet P2016J3/414P stereo. I've measured its position. I've shown that it matches the expected aberration for stereo on the opposite side of the solar system, not for Earth at the time. I've also used stellar aberration to calculate the positions of stars very precisely so that I can align the telescope you see behind me on multiple stars in order to de novo track various objects traveling at high velocity at great distances, including the Chinese space station as shown before, Fram 2 as shown before, Starship, and others. So I will continue to do that kind of work. I open source my code. It's available on my GitHub page that you can check out on my YouTube channel. Channel members, I'm going to shamelessly plug myself here for a second. Channel members can also download pre-compiled executable versions of my Sat Tracker and Rocket Tracker programs. And as mentioned, those programs, particularly Rocket Tracker, now has this planetarium feature that lets you align on multiple stars in order to achieve the utmost accuracy in tracking objects, which is especially important when you're trying to track something like, say, Starship Engine shut down from Florida in a bright blue sky where you can't see it, and only the telescope can see it, and only if it's pointed at exactly the right location at the right time.
And I know we're going to get this question later, so I'm just going to ask it now. So Astronomy Live, can you name the 2 telescopes that are in the background, please?
Yeah, great question. So the big black one behind me, this is an 11-inch Nexstar GPS. It is the predecessor to the CPC 1100, and then the little orange one next to that one is the Nexstar 4SE, which is kind of my little grab-and-go scope, mostly used for testing purposes.
Understood. Thank you very much. This isn't a question, but a statement, and I invite statements in the other direction. So if you want to say that Astronomy Live is a big meanie head poopy pants with a super chat, be my guest. But for $5, Braun with a 3 for a B says, Alan, thank you for bringing nothing like every other flurf. Thank you for the super chat. Like I said, if you wish to be rude for towards Astronomy Live, be my guest. So we'll make it even. I have here a comment from Big Fish V32. I'm going to restate this as a question. Alan, do you consider presentations to be more involved in terms of the work that you have done, or do you consider what Astronomy Live has done to be more involved in terms of the work he has done to support his claims?
It's different ends of effort on the same spectrum, man. He's out there doing his thing. I'm doing what I can do.
Okay, so you see what you're doing as equivalent to what he is doing?
Is it any more important or less important?
No, it's just a matter of your opinion.
We're doing the same thing.
Okay, thank you. So let's see. For Atlas 6355 for $4.99, he says, I asked you and your audience for one flat Earth prediction and I got timed out on your channel. Care to share one prediction? Let's rephrase that. I'm going to say, what prediction, given what you have studied and the map that you have presented, if we were to utilize what you have presented to make a predictive model, would that predictive model actually work?
Yeah, it would be a predictive model with a flat baseline. So there is some predictions and stuff that we could do. There's this new development called the celestial theodolite. I don't know if you guys have heard of that or want to get involved in that, but that'd be a great one.
Okay, I'm just going to jump in here and say I would love for our next conversation to be about your celestial theodolite.
Yo, well, we're having an update on Monday at 8 p.m. Eastern on Discord. If you're familiar with that, I can give you the links and stuff if you want to hop on for our annual update.
I won't be available at that time. And in fact, my schedule is going to get real busy
here.
Oh,
no worries.
I've got a contract starting coming up next month, but after the summer, maybe in the fall or even winter. I hate to say it, but
dude,
at some point, I would love to have a conversation with you about your celestial theodolite.
Dude, hit me up.
All right, so the next one for $2 is a correction. That's 3 for 3, Ron. My apologies. Thank you for the correction. MC Tune Live for $1.99 says, AS, I assume that's supposed to mean AL. Okay, so Astronomy Live is a meanie poo-poo head. There you go. Unfornicated for $2 said, Astronomy Live, so you haven't done any actual work, JK?
No, just fake work. Just
fake work. Okay, cool. Astronomy Live is a meanie head poopy pants. There we go for another $2. Yeah, I didn't think you guys would take that shit seriously, but thanks, I appreciate it. Vadim says for €5, fair meanness towards red. You are very offensive towards pigs on your radiator. That was a low blow, man. I don't appreciate that. Okay, so for $5, Monkey Cat Pat Pat says, Astronomy Live, you haven't done any street activism, so you have done no work. So question, Astronomy Live, have you ever done any street activism?
Does sidewalk astronomy count as street activism? I mean, I'm active. I'm on the street with a telescope.
I mean, I guess it works. Okay, so with that, it looks like we're done with all the serious questions. So thank you guys for participating. So who won in this poll? This poll is now 8 minutes old, so plenty of time has been given, so everyone else can get their votes in. And the results are this: Alan 13%, Astronomy Live 87%. Going to go ahead and end that poll. I'm going to say thank you guys for jumping on. I really do appreciate it, and thanks for keeping it civil. I know these things can kind of turn into a clusterfuck, and I'm happy to see that it did not turn into that. If we wish to have a follow-up to this conversation, we can do so. Let's just schedule it for the future. So with that, let's go ahead and close out. Alan, say what you guys say, and get the fuck out.
Thanks for hosting. If you want to learn more about ether cosmology, you can go to spaceaudits.net, and all my links are there. Thank you very much.
Thank you. All right.
And with that, we're going to go ahead and wrap up. So let's see here. Tuesday will be Ether Cosmology Roundtable number 84. Be prepared for that. I'm not sure what we will be doing, but it will be something. And then Monday will be Celestial Theodolite Update numero 6. It'll be the 6th one, I think. So tune into that. And thanks for the support, everyone. You guys are awesome. Head over to the Discord and hang out.